Alright guys, so I was asked to make a little video about salt solutions and just talking through that. And so I've made up a new problem here that says what concentration of sodium benzoate, NaC7H5O2, is needed to form a solution with pH equals 9.6. And what I would really recommend you guys do is pause this video right now and work this out, and then watch the video and compare what you do to what I've done. I think that would be extremely valuable, and I cannot urge you strongly enough to actually do that. But if you don't want to pause it, that's cool too, and I will explain what's going on here. So the question is, what concentration of sodium benzoate is needed to form a solution with pH equals 9.6? And right away, again, I'm seeing sodium benzoate. I'm thinking to myself, okay, that's a salt. If I put that in water, it's going to dissociate into Na plus this benzoate minus. Again, the next thing I'm going to be thinking about is hydrolysis with water. Is either of these ions going to react with water? Sodium, again, hopefully we recognize that that's not going to react with water, but benzoate will. And I can write out this equilibrium, and again, I'm recognizing that as a Kb type equilibrium. I've got OH minus here. You know, the general form base plus water gives us conjugate acid plus OH minus. That's a Kb. And, you know, at this point, I don't know what that Kb is, but I do recognize this benzoic acid. So if I look on my, you know, table 16.1 right here, I've got benzoic acid, and it's got a Kb value, it's got a Ka value of 6.3 times 10 to the minus fifth. So I can use that information to solve for the Kb value for this benzoate ion. 6.3 times 10 to the minus fifth, and that's going to equal 1.6 times 10 to the minus 10th. So I've used the Ka information from my table, right? I've used this Ka information for the conjugate acid to solve for the Kb for this conjugate base. And that Kb value, again, here is 1.6 times 10 to the minus 10th. All right, so the question is asking what the initial concentration should be for this given pH. So in my ice table, I like just doing an M in brackets for my initial concentration there because I don't know it yet. Plus X, as we're probably used to doing by now. And now, again, using this pH information, pH equals 9.6, I can use that to find what my X value is. So if the pH equals 9.6, pOH then would equal 4.4, right? 14 minus 9.6 should be 4.4. And then my concentration of OH minus will be 3.98 times 10 to the minus fifth. And that is, again, right, equal to my X value. That's the value I'm going to be plugging in here. So let's go ahead and do that. My Kb, 1.6 times 10 to the minus 10th, equals 3.98 times 10 to the minus fifth. 3.98 times 10 to the minus fifth. And I'm ready to now solve for my initial concentration. Before I do that, I do just sort of want to urge you guys to, again, write out all of this information, right? A really common mistake is to use the concentration of H plus here where you're supposed to be using the concentration of OH minus. If you write out this equilibrium, you know, it will be really obvious to you, hopefully, that you're using the wrong thing. You'll catch that sooner rather than later. But if we solve here for our initial concentration, we get a value of 9.9 molar. that's the initial concentration of that sodium benzoate that I would need to form the solution with a pH equal to 9.6. Again, if you have any questions about this video, let me know, and I will hopefully clear those up for you guys.